the ship and there's a fire in the terminal, one of the things that the port personnel would be preparing for departure just in case it becomes necessary for the ship to leave. And once that word is received, obviously the ship, with the tugboat assistance and whatnot, can depart the area. Fire on board the ship or on the barge. My goodness, all of this is so very, very familiar, isn't it? Once again, we're going to sound the alarm. We're going to account for our personnel. An ESD is going to be generated when we have a fire. We're going to stop the source of a leak if at all possible, employ the water deluge system as required and as needed. We're going to assist as required. This is a little different scenario when you have a ship-to-ship event or a barge-to-ship event. The receiving vessel could very well assist the bunker ship or the bunker barge if there's an emergency on board because you're in such close proximity. The ship's water deluge system, if there's a fire on board the barge, obviously the ship being so close to the barge would in all probability activate its water deluge system as well. We can train fire hoses from the ship towards a barge. So in this particular case, the ship board personnel could get actively involved in an emergency response on board a bunker ship or bunker barge, which is made fast alongside the vessel receiving bunker. So this is one of those occasions, a little bit different than an actual fire within the terminal confines. The ship would prepare for controlled or emergency release if necessary, and ready for departure, releasing lines, disconnecting, connecting. We have those emergency release couplings. It becomes necessary for a ship to depart immediately. Obviously, the powered emergency coupling be released so that you don't have to have personnel coming on the ship to physically disconnect your loading arms from the manifold, the dry brake coupling, or talking hose situation connection. Another emergency that we could be confronted with, and a pre-procedure is going to be established for the loss of pipeline containment. I don't know of too many instances. If you read through the safety history of international LNG operations, there's a couple of there's a couple of instances in there, I believe, where pipeline integrity has been compromised for one reason or another. It's not a common experience, not a common incident. I think, as we talked about earlier, incidents of this type are most commonly associated with the commissioning of a facility, the commissioning of a new part of a system within a facility and whatnot. So this, when we're doing these commissioning operations, and this is basically pertains to people on board LNG carriers where they're going into LNG terminals, perhaps a new system that has been implemented, put into service, and it's commissioned. These are the occasions which something of this nature potentially could happen. And as I said, it's not very common. But again, the procedures that are going to be followed are very, very similar and very much the same as we have seen with other emergencies. The alarm is going to be sounded. Personnel are going to be accounted. The transfer is going to be stopped. Most important thing to do in any emergency situation is to stop the transfer. If it's not done initially by the ESD system, it will be done by operators. But the fact is that the system is going to be shut down and put into a safe condition. so that we can now concentrate our efforts on the emergency at hand. We don't have to worry about cargo movement, vapor movement, or anything else. Uh, Water deluge system is going to be used. It can be used to direct the vapor cloud. It can be used to it can be used to protect property, protect whatnot, protect personnel. Uh, we isolate the breach section of the pipeline. All of your pipelines are double valve protected. Uh, in any time in any pipeline where you have a double valving arrangement, you're also going to have the means to relieve pressure, because when you have LNG in a pipeline and you close a valve here and then you close a valve here, you've got a section in here where the liquid is dead ended, and anytime you're dead ending a liquefied gas, it's going to be vaporized, it's going to be evaporating, and as it evaporates, pressure is going to build up. So anytime you have a section of piping that you can isolate from another section of piping, it's going to be a means to relieve pressure from that pipeline. It's going to go to a vent riser. It's going to go back into the vapor system of the plant, whatever the case may be. But what you want to do, in case there's a pipeline containment, is you're going to isolate the breach. So that section will be isolated. Vapor is going to be relieved back into the facility. Gas concentrations are going to be monitored. A primary purpose of our gas detection. We want to know what the concentration of gas is in the area around the breach, in the area around this information arrive closely monitoring our gas detection system. We also have the availability of the portable gas detector that personnel can use to approach an area and monitor manually by hand. All you know exactly what the concentration. Overfilling of a cargo tank is another emergency that can happen. The preventative measures that are going to be employed to prevent that. You have your gauging, your tank level gauging system, which has a high level alarm. We're going to alert the operator that you're approaching the full level of that tank. That alarm is initiated. Action can be taken by the operator, and that tank can be is so designed. The system is so designed. Hit a high level alarm. Fill valve of that particular tank can automatically close. If that system itself doesn't properly work, you now have what's called the independent level shutdown, which is often referred to as a high level shutdown. And if that physical point is a physical point within the tank that liquid touches it, going to generate an emergency shutdown. And not only will it shut down that tank, it's going to shut down the entire LNG transfer or the bunker transfer so that we don't overfill a tank. The rare occasion where a tank has been overfilled, and this hasn't happened in years, it did happen in the early years of LNG operation. Any case that I have ever heard of, operator error created the overfill, resulted in the overfill. Safety system compromised, safety ridden. This is a prohibited activity on board ships now. No safety system can be compromised and overridden. Anytime something like this is done, it has to be done with the full consent of the master and the chief engineer. And if a safety system is overridden, you have to take backup action on how to make sure that human error does not enter into a situation where a tank can be overfilled. Very, very rare occurrence, that, and I don't know of any in recent history. If there is a system failure, The logic system of the integrated automation system for your tank level system is going to initiate an ESD. Uh, uh, the integrated system is a system that is continuously running self-tests and self-checks, and if anything in this self-testing or self-checking fails, an emergency shutdown will be generated. Liability of the systems is such that this is also a rare occurrence. It does have the it does have the check. If anything out of the ordinary and the system sees this isn't working properly, we will initiate a shutdown, and thereby you're going to prevent overfilling a cargo tank, overfilling a bunker tank. The alarm will sound. Water deluge is going to be water deluge will be activated again to protect personnel and equipment. Use water spray. You can use water spray for vapor control if, in fact, that you get an overfilling scenario. And at all times, we're going to be monitoring tank pressures. Cannot be distracted. One incident, one emergency can't distract you to the point where you're ignoring something that could very well wind up into an emergency situation in itself. So situational awareness for the operators is absolutely critical, and measures are taken on board the ship to make sure all of the operating personnel have received the proper amount of rest. This is a major issue in the maritime industry nowadays, guaranteeing that seafarers are well rested any time they're involved prior to their operation, their cargo operations or their bunker transfer operations. Seafarers are required to have a certain number of hours of rest prior to engaging in these activities, because over the years, accident investigations have revealed that one of the primary causes for accidents are fatigue. Manning scales are such on ships nowadays, and I believe truly that this also carries over to terminals. Everybody is trying to minimize manpower, and it seems the more technologically advanced we get with our integrated automation systems and backup systems that's all electronically controlled. There's a segment of the industry feels that, well, we need less personnel now because we have all of these automated systems. Well, eventually you reach a point where you are down to minimum manning scale. Mans on board personnel interport are very, very high. I had an article here that I pulled out, magazine, that just arrived at my house. If I find it, I'll see if I can send the link to you, Jared. And what the article is talking about, how seafarers don't like going into port. Now, this is something that's totally contrary to what people. Years ago in simpler times, years ago when I started sailing, we always looked forward to getting into port. That meant we had some time to go ashore, time to relax, vent. Oh, we can't hear anything? Jared, is my audio gone? Okay, I'm getting yeses. I don't know if
Hey,
that's
John.
yes you can hear me or yes you can't.
We can hear you over here just fine. I'm not sure.
Okay, fine.
A couple of the
Okay,
students.
fine. One of the students posted that they couldn't hear. Okay, so anyway, this article, just talks about, going into port today, the demands that are placed on board the personnel on board ship when they go into port are usually very, very high. Many activities take place when a ship goes into port. Inspections are being conducted by various agencies, class societies. Coming into U.S. ports, there's Coast Guard inspections. There's vetting inspections. where potential customers who are going to charter a ship or use a ship, they'll come and inspect a ship to certify that the ship meets their necessary requirements and whatnot. You have all types of things that are going on board, which puts a tremendous time demand upon the people on board the ship, and fatigue can become an issue because we're working on board ship. We're working within constraints that are mandated by regulation on how many hours personnel can work in a 24-hour period, a 72-hour period, how much rest they're required to have in that. And when this is interrupted by a port call, this can become very, very difficult to manage. So the article, just makes it clear that times have changed so very, very drastically. That sailors don't like being in port. They'd much prefer to be at sea, where they have a set routine and their hours are much more predictable. That was an aside. Jared, I'll see if I can find that article and I'll get it to you at some point in time. If there's an LNG leakage, a vapor leakage, there's going to be a gas alarm. The title of this particular slide is Loss of Primary Barrier. This could most likely occur in the membrane type vessel. The tanks, the way tanks are constructed nowadays, this is becoming less and less an occurrence. The early years of membrane tanks, they were subject to leakage, and it's only been through experience in the advance of technology where the containment systems have become much tighter. The tolerances are very, very small. Inspection procedures have been greatly increased, and the reliability of the tanks is very, very high nowadays. But in the early years, membrane tanks were subject to leaks, and these leaks were initially indicated by the gas detection system. You're monitoring the environment in the interbarrier space between the layers of two layers of material, whether that material was stainless steel or whether it was Invar. You monitor the space between them with your gas detection, and if the gas concentration in that space reached 30% of LEL, once again, 30% of LEL, which is 30% of 5%, an alarm sound. And then measures would be taken to dilute any gas that's in that space. Obviously, you couldn't immediately make a repair, but what the vessels had is they had the capability to continuously purge these spaces with nitrogen. So you continuously pump a large quantity of nitrogen into these barrier spaces to make sure any leakage into them is kept within safe limits. Another way, that would be another indicator of a leakage into the from the primary barrier. There would be a rapid increase of pressure in the interbarrier space. Again, the pressure of that space is one of the things that's monitored on a 24-hour a day, 7-day-a-week basis. So if it may be the pressure in the, say in the primary barrier space was 5 kPa, and all of a sudden that pressure increases to a bar, obviously you've got something going on in that space, which would lead to investigation and action to relieve the situation. You could also have indication of a leak by a temperature alarm. Temperature of the inner barrier space is also monitored time, and between the primary barrier and the secondary barrier, since it's close to the actual cargo, that temperature, let's just say, for instance, would be like minus 25 degrees C. If all of a sudden that temperature started getting colder rapidly, let's just say it dropped down to minus 80 or minus 90 in a very short period of time, this would be an indication that there's liquid leak. And also, the inner hull temperature on the membrane ship monitored tank actually actually the port system tank, the inner hull. All of your LNG carriers, excuse me, all of your LNG carriers are double hulled ships. You have your outer hull, you have your inner hull. The space between the outer hull and the inner hull for the segregated ballast, so that when you're, and this is the same for an LNG barge for a bunkering operation or a small LNG ship. When LNG is transferred from the ship to the terminal at a discharge terminal, the vessel simultaneously will be taking on ballast water into the segregated tanks. And what this allows, it allows the vessel to be what's often referred to in the industry remain at constant draft. Uh, Not entirely true. The draft between a loaded LNG carrier and a empty LNG carrier carrying ballast only is within 1 to 2 meters. But for all intents and purposes, that's considered to be a constant draft. If you're looking at a oil tanker, in contrast, a loaded oil tanker and the difference between a loaded oil tanker and an empty oil tanker, you could be talking 15, 20, 25 meters different draft. That doesn't occur in the LNG trade. The ship's so designed that the ship loaded or in a discharge state, relative, pretty much the same. So if we see on the membrane type ship, that inner hull, the temperatures are going to be monitored because the inner hull is part of the support system, the containment system. We see the temperatures in that inner hull dropping for some reason. This could be an indication, possibly we do have a leak pipe. Again, the construction of tanks today is such that leakage in the membrane tanks is rare. It's very, very rare. Leakage with a spherical tank, I don't know of any instance where a spherical tank had a failure where it's had a leak, mainly because of the type of construction, a much more robust tank. Talking steel, stainless steel, aluminum, materials that are very, very thick. Leaks in a spherical tank, I don't know of any document. But also in a spherical ship, you do monitor the hold space temperature. That's that space in which the spherical tank is mounted. The temperatures are monitored. It would take a rather substantial, you saw a temperature difference. Temperature could be the insulation spaces in those tanks monitor temperature, pressure. In the spherical tank scenario, temperature, pressure systems are in place, still employed on any new construction, even though the number of leaks is such a small number, but part of safety system in the construction of LNG carriers. If there is a leak into one of these spaces, the procedures that are outlined in the cargo manual employed. These include, obviously, be the notification to corporate headquarters that you have a problem, and I'm sure this would be immediately followed by telephone calls, satellite, the procedures to correct it as possible. Be an effort that we coordinated with their corporate. Loss of gas burning capability. All of your LNG carriers are dual fuel vessels. The majority of them, when they're in port now, they gas, almost 100% gas. This gives you the ability to control the vapor from the boil off in tanks, and it's also environmental friendly, just the way things are done. Steamship, the fuel is the boil off is sent to the boilers and is used as fuel. If it's a motor ship, your diesels nowadays, your modern diesels all have dual fuel capability, and they can burn up to 100, up to almost 100% gas. Both a boiler on a steamship and your motor ships They will also simultaneously be they'll be burning a small amount of a light fuel, which acts as a pilot in case gas capability is lost, so that that engine immediately will switch over to uh, the the uh, the heavier fuel and will continue to operate. Uh, it's all part of the safety system. It's all part of the backup system. On some of your diesel motor ships nowadays, uh, there are reliquefaction units, and the uh, boil-off gas is reliquefied and put back into the tanks. But you still had to have it rather than being used as fuel. These are on a class of ships that had slow-speed diesels, and there are not as many around as I thought there would be at point in time. Uh, I don't think it seems to be the preferred method nowadays, but on ships of that type that use reliquefaction units, you had to have a means of boil-off control in case you lost your capability to reliquefy. So these ships had uh, installed on them a unit which was called the GCU. That's called a gas combustion unit, and you had the ability to use your boil off, fire it through this gas combustion. It's almost like an afterburner or a jet engine where you could start this thing up and your boil off could be dissipated through the gas combustion. Uh, you also have your gas fueled alternators or generators. Motor ships, these are your alternator generators are controlled by a diesel engine. You have your pressure relief valves. This is probably your last line of defense. All efforts to rid the vessel of oil-off gas can't fully control it. When the tank pressures reach a certain point or certain pressure, these relief valves will lift and will relieve the boil off or relieve the vapor to the vent mass. Another method is controlled venting. This is preferable to using relief valves or letting relief valves lift. If you have to do controlled venting, you can route the vapor through a heater and warm it up so that when that vapor is emitted from the vent riser, it's at a warm temperature and immediately rises clear of the ship. If you lift a relief valve, vapor that's going to go through that relief valve is going to be cold vapor, and you have that possibility of when the cold vapor exits the vent riser for that particular tank, it very well could be at such a temperature where the vapor is heavier than air and actually sinks down, comes down onto the ship and onto metal surfaces and whatnot. Uh, another reason no one wants to lift a relief valve is when a relief valve lifts, you you want to be 100% certain when when the pressure is relieved that relief valve seats properly and that there's no leakage by it. So the best way to make sure that you don't have a leak in a pressure relief valve is not to have that valve lift, because anytime a relief valve does lift, you do run the risk of it maybe not seating 100%, and there may be a little a leak past that relief valve, which can present a problem when you're going into port. But the relief valve is an integral part of the pressure control on board a ship, and is one of the lines of defense if gas burning capability is lost and you have to relieve excess pressure. Ballast leakage into the containment space, because on your membrane ships, your inner hull, which is the inside of the ballast tank, right up against the insulation of the cargo tank, always have that possibility of a water leak into the hold space. So we do have the means to monitor this. There's leak protection system where water actually will accumulate in small quantities into a sump. If this does in fact happen and you have a small pump, a bilge ejector, which would actually eject the water from the hold space off the ship. The secondary barrier, which is the outer barrier, if that has a failure and there's leakage, we'll have ice building up in the insulation. Insulation could be damaged and going to have high dew points. These spaces are monitored on a regular basis, not only for temperature and pressure, but we also monitor the dew points to make sure that there's no moisture accumulating in these areas. Nitrogen supply failure. This is prevented in part of our emergency operations, emergency procedures. You have redundancy with your nitrogen generator. Any ship that has a nitrogen generator is going to have a backup units, and these units are alternated on a regular basis. You also may have a buffer tank, storage tank for nitrogen in case there is a nitrogen generator failure. You have a large quantity of nitrogen that's going to be stored inside the buffer tank. Also, you may have nitrogen bottles, large bottles of nitrogen under pressure, and we'll have a supply of that again is part of the backup. The older ships used to carry a tank on board, and that tank would be routinely refilled in either your load or your discharge with liquid nitrogen. So you had a large supply, usually in the order of 20, 25 cubic liquid nitrogen. So you always have this backup and this redundancy so that if there is a nitrogen supply failure, you have sufficient quantities on board for backup until repairs can be effective. Power loss. Power loss, what you're going to be concerned with if you have power loss, you're going to have a shutdown, and pressure control is going to be the issue here. So you want to have the ability to maintain pressures and leave pressure if at all necessary. Okay, I'm not quite sure how many more slides we have in section 18. Double check. I think we're getting close. Yes, we are. We're almost at the end. Okay, I think I can finish. So on board ship, if there's a part of that evacuation system is going to be mustering the ship's crew per the ship station bill and the emergency procedure instructions. Same thing for a terminal. They would do exactly the same thing. We're always going to account for our personnel. Other persons on board the vessel, visitors, inspectors, vetting people, officials, port officials, and whatnot. When they come on board, they're given instructions on what to do in the case of an emergency and where they should go. Oftentimes, if they're on board the ship, they would muster on the bridge of the ship so that they can be accounted for. Any personnel coming on board the ship, leaving the ship, they're logged on board. So the ship always knows how many people are on board, what their function is, and where they're going to be located. Shore personnel are going to proceed to the terminal muster stations or gathering points, and any visitors, anybody who is on board station at the terminal will be following the instructions of the terminal staff. Very, very similar to what we're instructed when we go on board an aircraft. Follow the directions of people on board. These are the people who have the expertise and training and know what you should do, when you should do it, and how you should do it. Just listen to the ship's crew or to the terminal staff. The best practice is still to do all you can to prevent an emergency situation, prevent a fire. An emergency develops, we have a strategy in place, and it's ready to be implemented through the emergencies procedure manual and through the emergency plan. It's important that all personnel clearly understand how to manage these strategies and procedures. And it's important that everybody be kept informed as to who is doing what, where they're doing it, and how they are doing it. And as long as these procedures are followed, we can effectively handle any type of an emergency situation, and we can get through these things with minimal damage to property and and hopefully no injury or damage to personnel. And that's the end goal, to keep this operation safe. Safety first, at all costs, safety first. And that is a wrap on this section. Think. Oh my goodness, I'm early, huh? 14:35. Okay.
Hey, John.
Yeah. Do we have any?
Yeah, so
Yeah.
we were
Do we
just
have any
discussing
questions?
what we were gonna, what the students here prefer. Um, if you want, it looks like there's just the one presentation left, 319. It's about 20 slides. So
Yep.
we're about half hour early from the break. If you want, we can just push through. I think that's the consensus here, is to push through and finish 319, finish early, and then we can have an early afternoon.
Oh, all right. If that's agreeable with you folks, let's do it.
All right, I'll give 1 second to the students, the remote students, if there's any issues with that.
Okay.
If there is, please type in the box if you'd like to take a break now. Going once, twice. Okay, I think we can continue.
Okay. The consensus is to continue. Okay. Very, very good. Uh, before I jump into section 19, if you haven't had a chance to take a look at that safety history of international LNG operations, if you have copies of it and it's available at some point in time, uh, kindly go to page 23. It's a 27-page document. Go to page 23, and that is the report of that LPG ship that I talked about earlier on in the course. The Yo-Yo Maru, that's the one I told you about, that we used to have a video of it years ago on board the ships. It was the LPG ship that was involved in a collision, fatal collision, unfortunately, in Tokyo Bay, and an awful lot of people, unfortunately died in it as a result of the fire. Uh, this I think is a very, very informative article, in the sense that so many people who don't have knowledge of LNG, the LNG business, the LNG trade, are afraid of an LNG ship exploding. And this article is going to explain exactly what happened to this ship, and how long it took for this ship to be destroyed. The danger, the primary danger with an LNG ship of collision and a breach of a tank, fire. Unfortunately, it's fire, because we are dealing with a combustible product. But explosion is essentially not an issue of major concern, because of the nature of liquefied natural gas. And in this particular article, we're dealing with LPG, which in actuality is a much more volatile product. This is a product that moves around in various ports of the world without as much as a second thought in many cases. And nobody pays a whole heck of a lot of attention to it, other than the Coast Guard in the United States. They're right on top of it. But LPG ships move around with a much greater deal of freedom than an LNG carrier can when it's entering port. And my personal opinion is they're probably a much more volatile ship. But you will see that when you go through this article, this vessel was struck with bombs, torpedoes, and everything else, and they could not get this ship to explode. Eventually, fire was the cause of the demise, and actually it sunk because of damage from all of the ordnance that was pumped into it. But the propane tanks never did explode, which is interesting, because this is always a concern: explosion. Fire is the primary danger, and of course, we'd never want to see that fire scenario. But in any event, I think you'll enjoy that. You'll enjoy the article. Okay, I'm going to open up 19 and we'll move along and wrap. Okay, section 319, emergency plan for bunker supplier and bunker receiver. I think as you can probably guess, we're not going to see really a whole heck of a lot of new information. What we're going to see is a repeat of those procedures that we have laid out that apply to the LNG ships and to LNG terminals. And it will be incumbent upon the bunker supplier and the bunker receiver because we're now away from the scenario where we're dealing with LNG carriers with the people who are accustomed to using and transferring and carrying this. We're now into that area where, okay, we have, for instance, a ferry boat, passenger boat, passenger ship, small offshore vessels and whatnot, which traditionally have been powered by your intermediate fuels, your diesel oils and marine gas oil and whatnot. And because of our economic and environmental concerns, we're now starting to see this conversion over to natural gas. So they're dealing with a product that they have never had to deal with before. So they are going to have to devise emergency plans. The bunker supplier and the bunker receiver, each individual company will devise their emergency plan. Be a little bit different for the supplier than the receiver, but it's going to have to cover all of those things that we have already touched upon in previous sections of the presentation. It's incumbent upon them to identify the different plans in case, and also the incidents if an incident does occur. So what they have to do is they have to go through all of these various scenarios. This can be done in collusion with companies that already have a plan in place. It can be done with consulting agencies who are very, very well versed in various aspects and incidents that could arise. So there's certainly an awful lot of help out there. So the supplier and the receiver, they'll have to bring these people in. They're going to have to hire them if they don't have them on staff so that they can sit down and go through the various case by cases that they could be confronted with and how to respond to an incident if something occurs. That they provide reasons why clear and instant communication between all parties are critical when dealing with an emergency. This is something that maybe was not such a big deal when we were dealing with intermediate fuels and gas oil and diesel oil, but it becomes critical now when we get involved in the transfer of natural gas. And they have to illustrate a chain of command in the decision-making process. This is all part of their emergency procedures in their emergency plan. Various resources that you can check into. The EU has their own standards that are codified, and these are the ones that apply in the U.S. These basically are the IMO standards, which have only been codified under the U.S. federal code. And the references that we use here are by the Occupational Safety Agency, Incident Command Handbook, and the U.S. Department of Homeland Security. These are the various agencies that promulgate, that enforce the international rules and regulations and also promulgate local regulation. In the United States, we use this National Response System and Incident Command System, and we have the Federal Emergency Management Agency, FEMA. They will also promulgate various regulations. So these are the sources that a company in the U.S. would avail themselves of, and there's certainly enough information available from these agencies where they can devise an effective emergency plan and emergency manual. It's necessary for the supplier and the receiver to make maximum use of resources that are already out there, the expertise and knowledge and equipment that's currently in use in the industry on board the ships and on board the terminals, and what the bunker supplier and receivers are going to be employed. They will also avail themselves of local services, the authority of local service, their local fire service, local law enforcement service, your local emergency service. All of these agencies now come into play, which maybe perhaps didn't to such a large degree for dealing with the other types. But because of the nature of LNG, the plan is going to be reflect the fact that we're now using this little bit more volatile fuel source, one for which there's more public awareness and more public concern. So we have to take advantage of everything that is out there in order to come up with an effective plan that first of all assures the safety of personnel, assures the safety of property, and also assures the safety of the businesses, people, and personnel in the areas that surround locations where these LNG bunker transfers are going to take place. Part of the emergency response plan for both is to establish a chain of command for first responder agency, emergency services, your management service, fire service, state, national, providential, law enforcement agencies. It's all done through incident command system, and this becomes part of the emergency procedures and emergency plan for the bunker supplier and bunker receiver, as it does for any other entity that's involved in the transport of liquefied natural gas. This is a chain of command example that would be established in the plan. You have a unified command of your federal, state, and local officials, or an incident commander. Usually the first person on site becomes the incident commander. If you do have an incident, and this is expandable as the incident expands. If the incident becomes larger and larger, this incident commander may in fact change as different agencies are brought in. But there's always going to be one incident commander, and underneath that person you're going to have these various operations. It could be one individual maybe handling one or two, or it could be, if it's a large incident, you may have an individual handling each one of these things. This has been devised because it provides a smooth flow of information, a smooth flow of command. Who knows? It's this way everybody knows what each person is doing. The purpose of it, the incident command system, is to stabilize the situation, rescue and treat casualties, safeguard and evacuate civilians if it becomes necessary, and minimize damage to property and the environment, and also to prevent the escalation of the incident. And by establishing this type of command system, we find that these goals are accomplished. If you have never taken a course in incident command, not the most exciting course in the world is an understatement, but it does give you an understanding of how this thing does function. And as laborious as it might seem, it does function well and it does work well. We're going to develop an effective action plan. Again, this is part of the this is part of the emergency procedures. This is part of the plan. In this plan and procedures, roles and responsibilities are identified. what has to be done. And then we can say, oh, this is the person, this is the entity that's responsible for that. We're going to develop practical situation-specific scenarios based on emergency and exercise. Uh, this reverts to training, 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 drills and training. Each time we do a drill, we learn something new. Each time we do a training exercise, we learn something new. So that each time we conduct one of these things, uh, our knowledge base is increased. Our ability to respond to an emergency situation or an emergency uh, incident is better. And this is the purpose of it all. We're going to develop practical location-specific emergency procedures and exercises. Uh, the location of a terminal, the location of a bunkering facility. Uh, the procedures may vary somewhat from one location to another based on the local environment, based on how many buildings, all of these things that we touched upon in earlier sections, all of these things that can affect a spill or a vapor dispersion cloud and whatnot. Methods may be a little bit different from one location to another, so we do come up with locations procedures. Uh, this does not mean that there are not common things that we do, as you've already seen. Certain procedures are going to be common wherever the emergency occurs. Certain things that are going to happen in a sequential manner, but you can have location-specific things. We develop the effective plan of action, and that again is done through regular drills. We are constantly reviewing and updating our plans, and this is a consequence of the regular drills. Each time we do a drill, we may run into a different scenario, a uh, different consequence of an action. So as a result of that, when we finish the drill, we're going to sit down and we're going to critique the drill. And it's important for everybody who's involved in a drill to get involved in the after action segment of it. Uh, if you're involved in a drill and you see something that didn't, maybe it runs a little bit against your grain, or you think that can be done better, bring these things up and voice your opinion, because it could very, very well result in something that's going to make a better plan, a more effective plan. Uh, we're always looking for continuous improvement or management of change. These are the two phrases that are often used to indicate that we're always looking at our procedures, and we go through a continuous improvement process or the management of change process. And this is a specific way things get done. You can come up with a suggestion, and then the suggestion move up the chain of command, gets reviewed, and ultimately, if accepted, gets integrated into the updated plan. The receiver and supplier, they will meet and pre-plan emergency response with all of the local stakeholders. We've repeated this time and time again. The fire officials, the law enforcement officials, emergency management people, the medical people, anybody who could conceivably be involved in any type of incident response. Meet, pre-plan, meet, review. Train, drill, meet, critique, review. This is an ongoing process. Uh, the existing plan is always under scrutiny, is always under review, and you're going to receive feedback from your various stakeholders, and that feedback can be part of the management of change, and the plans can always be current and updated. You update the existing plan, the updated plan is going to include these LNG requirements, obviously. The bunkering operation, we're integrating LNG into the existing local emergency plans. When you go into any area, you have a port facility, regardless of where it is. That port facility will already have an existing local emergency plan. But now we're going to introduce LNG into it as a bunkering medium. So that's going to mean that their local plan is going to have to take this into consideration. And you have local area coordinating committees that meet regularly, and they meet with the various stakeholders and whatnot. So we bring LNG into the picture. So we're going to implement the continuous improvement management of change process, and LNG will become an integral part of their existing emergency plan. It's just simply updating the current plan. Uh, to ensure local responders understand LNG risk, pre-planning. Uh, it's going to be an educational process in some cases uh, where you have, port facilities and terminal facilities that have never been exposed to LNG. So there's an educational process that's going to have to take place first. Uh, they will have to understand the characteristics of LNG, the properties of LNG, a lot of the things that we have touched upon, all of the things that we have touched upon in this presentation. And 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 it's important that they understand that this is a very user-friendly product when handled properly. As long as the rules are followed, as long as proper procedures are followed, uh, the introduction of LNG is not a major issue. So they will meet with the first responders, EMS people, fire, law enforcement, and medical providers. We have to provide that education to these people because in most cases they really have very little knowledge of liquefied natural gas, and many of them are going to have a fear of LNG. And this is something we overcome by providing them with the proper information. And as you've seen in this presentation and in other modules that you're being exposed, sources of good information are unlimited, and it's important that they get good information. It's also important that they realize that there's a lot of misinformation and bad information out there, particularly on the internet, and they have to be careful. And you should be aware of this information as well, so that if anyone comes up with some ridiculous objection, you can counter that through your own personal knowledge. Stakeholders obviously, again, have to be involved in the emergency response plan. And LNG firefighting training has to be done by your local fire department. Uh, uh, I don't know how many times we've repeated this in the presentation. It's essential that the local firefighting have training. Many of them don't if they're not in an environment where there's a concentration of refineries and chemical facilities and things of this nature. Maybe a more traditional type firefighting force where their primary concern is fighting fires in apartment buildings, business and single family dwellings, things of that nature, where they don't necessarily have that need of knowledge uh, uh, in LNG or in combustible gas firefighting. So these local people may need additional training. So being brought on board early in the process, they can get that necessary training. Part of that educational process or educational program for the stakeholders is teaching them the characteristics of LNG, first aid and firefighting. Uh, you'll you'll go over first aid tomorrow. It's a fairly good module. First aid is it's very important that you have a knowledge, the dangers of dealing with cryogenics, what can happen, and how these any injuries resulting from that, how they're going to be treated, and what you're going to have to know and what you have to do. So this becomes also part of the educational training for the stakeholders, and also the emergency response plans exercises. This is the ongoing educational process that will take place. Uh, Unfortunately, I think, initially you may meet a little bit of resistance to this, but your knowledge is going to be your weapon of choice, and you'll be able to give people the proper information, which is absolutely important for success and implementation of bunkering transfer operations and the handling of products within the confines of ports and terminals. An integral part of the emergency response plan is, again, a contingency plan. We know what we're going to do. Happen controlled exercises, the regular scheduled exercises. We have these drills. We actually practice and system reference earlier, and you can see how this functions. That gee whiz, this does function well, and this is proper. The incident command system gives us that ability to standardize the approach to command in any emergency situation. We can control and coordinate emergency response by using this plan, and it provides a common hierarchy regardless of where you go. This is an internationally accepted system. So you could find yourselves perhaps involved in an emergency situation in the United States, and you are a crew member on board a flagship of the European Union. The incident command system used in the U.S. is probably going to be identical to that used in the EU. And so it's something that you're walking into something, you know exactly how this is going to work. The 5 functional areas of incident command are the command itself, the operations segment of it, marine operations, planning and logistics, administration, and finance. In most cases, when an incident occurs, my experience has been that incidents are usually of a not huge in scope. So you might not necessarily see the full expansion of the finance is going to get involved, administration and whatnot. This is this you'll find in a major emergency incident. Probably the best example I can use here in the United States in New Orleans in Hurricane. As mismanaged as that ultimately turned out to be, the incident command system did work, and this is the way it was set up. But because of the huge, the massive size of this incident, you had these various parts of the command system that were implemented, and they in fact did work. Though even though perhaps some of the outcomes were not as desired. Again, here's a graphic of the command staff and how it. So emergency plans are absolutely necessary as part of all LNG operations. Key to an emergency plan is the establishment of a clear and understanding chain of command. That's done. All stakeholders involved. They get involved in the training and the retraining. This established basis upon which work effectively with all of the various agencies that would be involved in any type of an incident. So it's absolutely necessary that these things be implemented. It's absolutely necessary that they be done. It's necessary that you have the knowledge of how these things work, so that when you are involved in any pre-planning operation, you have that awareness of how this all works together. And if done and implemented properly, you're going to have very, very safe operations. And it's one of those things where, 50 years from now, nobody will ever have read about your operation. And that's exactly where you want to be. The only way you want to have somebody read about your operation is because of its excellent record. And that's the goal that we have: safety first, foremost, and always. And that is going to be a wrap on the presentation, Jared. It has certainly been a pleasure for me to try to get this information, across. I can see where an awful lot of improvements can be made in the presentation, but hopefully the core information has been helpful to anyone who has sat in on these sessions. And it certainly has been a pleasure and an honor for me, even getting up at 2 o'clock in the morning to get ready to do these presentations. But again, thank you for the opportunity. Thank you for your attention. And if there's any questions, I'll be more than happy to try to answer them. Thank you very much.
Okay. Well, thank you, John. I really appreciate it. The World Maritime University appreciates it. And I think it was very enlightening over the last 15 hours you had with the students. You covered everything from modalities to characteristics to emergency procedures, transfer procedures, basically everything you need to know about handling of LNG as a marine fuel. Thank you for everyone for sticking through some of the technical difficulties. Like I said in the beginning, this is just something that we have to work through being a pilot course. As I'll repeat what John had said as well, there are improvements that can be made, and we will continue to develop the course. And at some point in the near future, we hope to have this course available as a what we like to call professional development course here at WMU, in which we're going to invite John to be a part of in the future. On top of that, we have a couple of things I want to reiterate while John is still with us. We have a postgraduate diploma on energy efficiency management, as well as a new specialization. Next year, the enrollment begins for maritime energy management. Both of these are heavily involved with LNG, and of course, there's none better than John to support that program. So we're going to pursue further partnership so that we can have him maybe come out to the university and be a part of our attending, visiting guests. And actually, I'm getting a phone call right now for our guest tomorrow from Mantech, who has just arrived. But I'll let that go to voicemail. So what I'd like to do here, I assume you all can hear me. Can you hear me, John? Okay, good. Okay, so this is a virtual thank you. We've already put this in the mail for you. It's a small token, but we would just want to say thank you. So you will be receiving a little tie, if you can see that here, from WMU. We also have a nice USB that you can carry on your keychain.
Perfect.
A pen that you can put on your tie here, and then a nice pen to go along with that. So that's already in the mail coming to you, and of course we will be working together in the future. You're more than welcome to stick around tomorrow with us and listen into Johan Lilleskold from Mantech to talk about some of his couplings. And like I said, we'll have some of the equipment here with us tomorrow. For the students, I would like to, well, let's just do this. I'm going to put you all on mic here. Maybe we can give a round of applause to Captain Egan here. Maybe it's not going to work out, but let's give a round of applause. Thank you so much.
Oh, great. I will give all of you a round of applause for sitting through the presentation. So here's for the students as well.
Yeah, very good, very good. Okay, so for tomorrow, we will begin class at 11, so 2 hours later than you did today, so you can sleep in. What we'll do is we'll begin with a 90-minute session on quickly about some of the PPE that you'll need for handling this LNG, and then also some first aid, first responder type stuff. Then we'll take a quick lunch break, come back, and then we'll have Mantech with us in the afternoon. So that would then conclude, well, let me just say this, except for a little bit of PPE and first aid, you pretty much have all the questions to your test. John has given them to you, and I've been very particular to make sure he's covered them all, and he's done a fantastic job. So there's no excuses for this assessment, although it's not quite difficult. I think you have all the material there for you. So you can sit back tomorrow and really listen in. There'll be some videos, and so it should be a good day tomorrow. And then Friday, then we'll do the assessment and the wrap up. So is there anything I missed from mine?
We start at 10.
Friday will begin at 10. The test will begin at 10, but I'll remind you tomorrow afternoon. Anything else, Demetrius? Okay. Okay. Excellent. Well, once again, thank you, John, so much, and I'll be speaking to you after we finish the course, and we'll make some plans for you to come out here and visit Malmo, Sweden.
No, thank you very much. I look forward to that. My wife is looking forward to it, so.
We'll try to get you out here in the springtime, so it's not so dark
Okay,
and cold.
it beats 2 o'clock in the morning. I'll tell you that.
Okay, well, that's it for
Okay.
Captain Egan, and thank you again, and we'll talk soon.
Okay, thank you very much, guys, and to all the students, once again, thank you for your attention.
All right, bye-bye. Hello? Yeah. Hey, sorry I missed your call. We were actually just wrapping with our other guest. So he just finished up the day.